Hello and welcome to an introduction to eltSnap. Today we're going to be talking about metadata management. We currently support three different databases to extract metadata from. The standard metadata refresh is the native SQL Server refresh. We also support Postgres as well as Snowflake. Now, the metadata management is used to extract metadata so you can later create ELT packages or ETL packages that leverage databases, table name, column names. We have code generators that work off of the metadata. So there's a lot of advantages to getting the metadata in, as well as our ability to populate drop-down text boxes for specifying which tables, columns, databases that you're using. The standard metadata refresh has a series of about 10 steps, but what is most interesting is, first of all, we have a data flow that will move data from the source data source server that you're targeting into the database table. You don't have to actually collect all the metadata from these database tables. After you run it the first time and extract all of the databases, you'll get a listing of them. Here's a sample of what they look like. So if the database is of interest in terms of metadata, then you can indicate that by placing a yes by extract the metadata for it. Also, if it's used as a staging database for type 2 dimensions, really type 1, type 2 dimensions, where you would specify which attributes in the table are the business key, are type 1 attributes, type 2 attributes, then if you're using it in that sense, you can also specify that this is a staging table. We currently are selecting from these two databases on this server, Dev, which is our SQL Server development environment, and Postgres, which is our a Postgres server that is newly installed. After that, we will extract for each of the databases where you specify you do want to extract the metadata. We'll go to the source database and server and extract all the table information, column information. And we use this pattern for it. This is what we call our for each data flow. And so instead of being a simple data flow where you saw the first example, this is a for each data flow, which will extract metadata for each of the databases where you indicate that you would like to extract the metadata. So you can see the for each query expression. And so any database that comes back from this will then be used in the second query, which in this case will extract the metadata from the proper database. The destination will go into the eltSnap database. This is where we house all of our metadata. It's best thought of as a little metadata manager built into eltSnap. And we're going to stage it. And we're going to stage it into the dimension table, 4 tables, and not to sound redundant, but yes, this is a staging table to hold table information from a variety of databases and servers. And of course, you have a couple of other options here to truncate or if it's an identity insert. To run this, you simply click on Run. It will invoke our own metadata manager, our own runtime system that will then populate this metadata data mart inside of eltSnap. And this shows you all the parameter settings that it's going to use. So the ETL framework, whenever we extract data from a source to a destination, we record row counts, run times, errors, etc. And so we store that information, and this is part of the standard package based on the template group that you choose. You can see the template group in the upper left here. So we chose framework logging. So this is where it'll log to. The eltSnap database is where it'll store the metadata. It'll use this friendly name for the server, and it's our dev server. And finally, it'll extract the information from this general purpose SQL Server connection. So I'll go ahead and click on Run. And now that has started the execution. I can look at the progress using our control panel. So if we refresh this, you can see the metadata refresh is running. And you can see the progress of each step as it executes. We'll go ahead and refresh that. Okay, it's done. So go ahead and close that. Go back to the front end. You can see you also have the information in terms of each step, when it started, when it finished, how many rows that it moved. And that is also logged in the metadata management database. So we have the very same thing for Postgres. And so if you're using Postgres and you want to extract that metadata, a couple of interesting things. The packages are about the same in terms of the number, but some of these are the identical packages. So for example, after we extract it from, in this case, Postgres, we want to merge it into our metadata database. We also have a standard Kimball dimensional model database. If I right-click and show dependencies, you can see that there are 3 projects that use this very same package. What you're seeing here is code reuse, and it's something that all software development approaches where you're dealing with a lot of code and you don't want to sit and recode for each package the very same modules or concepts. You need the rerunability. So many of these packages are in fact just that. They're rerunnable. Also, we use the code generators. This pattern is to execute SQL. So you simply will tell it what is your source connection and then give it the SQL to run against. This is a merge statement, and the merge statement is written for you. You can see, and if you've ever written a merge statement, you know how detailed and how large they are. So this not only takes advantage of the code generator, all you have to do is configure. Here's what the configuration looks like. You simply say, I want to go from this staging schema, dim table, to the actual Kimball dimensional model table, which is the same table name, but we use a DBO schema. And it bases all this on the metadata that it is pulling from our dev server in the database, which, if you recall, that's where we store all this metadata. Okay, so we can run the very same thing for Postgres. This is the first package. This data flow will actually connect to Postgres. We have this on a virtual machine. And you can see the Postgres syntax, which is going to come from PG database. But the destination is actually the same place, eltSnap. Also, we have the same thing with for each. So these are specific to Postgres. If I look at the dependencies, it is only one package because this is customized just for Postgres. So in some cases, you could reuse code. Other cases, you have to write your own. So we'll go ahead and run this one. You can see all the parameter values. These parameters, by the way, are driven by environment. So you can consider this your dev environment. So it would hit, for example, this particular framework server, or this is your local copy of eltSnap. When you promote this dev test prod, that's where you would use the environment. So you can run the identical package using a different environment where it will assign the parameter values specific for that environment. In this case, we're just running this for dev. So we'll go ahead and click on run. And now that'll start. And we can switch back over to the control panel. And we can see now that it's starting to run. A couple packages in. Go ahead and refresh. Okay, we're down to the for each data flow. And so we're about halfway through. Okay, just about done here. You can see the number of rows it's pulling over. So a total of 364 columns out of, let's see. Oh, that's the actual merge statement. So we only brought over 6 tables from Postgres, 59 columns. These are all the columns because when we we actually restage to make sure that we don't lose any metadata from another server that we brought over. So that would be the total of all tables and columns that we're currently tracking. So go ahead and close that, go back to the front end, and you can see that it did finish. We also have the same thing for Snowflake. Snowflake is a cloud-native data warehouse. It is very competitively priced. It works in Azure and AWS as well as Google Cloud. And it gives you true separation of compute and storage. So it uses a standard, for example, Azure Blob Storage or S3 in AWS. That's actually where the data is stored. And then you just spin up separate compute engines. So it's highly scalable. And so if you're processing a lot, you can create many compute nodes and process a lot of data. Then you turn them off. You don't pay anything except for the storage, which is about $30 per terabyte on S3 in Azure. So a great product. But in the same way, we can extract the metadata from Snowflake as well. For these, we use execute process. So this is the pattern will shell to, in this case, Python. And one reason for that is Python is a first class, or has a first class connector to Snowflake, so it's much faster than ODBC. So those are the three different databases that we support: SQL Server, Postgres, and Snowflake for metadata management. And of course, beyond that, we would use eltSnap for moving data. It's the reason we say ELT, extract and load. So we pull from your source operational system, be it SAP or Microsoft Dynamics or wherever your operational system lives, pull it into your data staging area for your data warehouse. That's the E and the L, just data movement, nothing more, no transformations. Then we transform using just native SQL, and that's where the execute SQL pattern comes into play. And we therefore take advantage of the very fastest engine that you have for transformations, which is your data warehouse server. So that's it for today. Thanks for watching. My name, again, is Jim Miller with BITrax Consulting. And if you'd like to contact us, it's at info@bitrax.com. Thanks again.